Okay, welcome back to Elements of Calculus 2. We are talking about U substitution today. So this is what we do with U substitution. Okay, so if we have an integral that's going to look something like 2x times, and I've got a, let's see, we've got 2x squared. No, we just have an x squared, sorry about that. And x squared plus 2 plus 1 cubed dx. Now, a thing you cannot do. So if I have an integral of f of x times g of x, you cannot say this is the integral of f of x times the integral of g. Like, it doesn't work this way. Okay, this is not going to work out at all. You cannot set this equal to each other. It doesn't work. So one of the things we could do is multiply this thing out and say, okay, look, what is x cubed or x squared plus 1 times x squared plus 1 times x squared plus 1, multiply all of this out, and then multiply it by 2x, and then integrate each term individually. Now, as much fun as that sounds like we could have doing this, I don't want to do this. Okay? There's a little bit of a way to like kind of see if we can't get by this without having to do this. Okay? Now, that way it's called U substitution. So what we're going to do is we're going to look for a u and a du to see if we can fit this into this integral without having to do all of this work here. So we're going to go ahead and say let u equal x squared plus 1, and every time you make a substitution in calculus, you take its derivative. Okay, you may not actually need it, but every time you're going to make that substitution, it's always good practice to take the derivative. And we end up with a 2x dx. Now, some books will have you say do this and say dx equals du divided by 2x, and that's fine. I learned it a slightly different way. I'll show you how I learned it. So we're going to say the integral of, and here we have our x squared plus 1 cubed. Now I'm just going to slide this 2x over to the side here, over to the other side, and say, well, would you look at this? This 2x dx, this is my du. So this is equal to, here's my du, x squared plus 1 cubed, that's going to be u cubed, but we can go ahead and integrate now. Everything is in terms of u, we can integrate. If you have x's and u's at the same time, you can't integrate, you haven't finished this yet. Okay, so that's just going to be u to the 4th over 4 plus constant of integration. So, but our answer is in the u's, our answer was posed in x's. So if somebody asked you, like, how are you doing this morning in French? You wouldn't say fine in Spanish, like you would have to respond in French. So we're going to go back to the original variable and say, okay, we have, what was my x? My x was x squared plus 1. So we're going to say this is 1/4 x squared plus 1 raised to the 4th power plus our constant of integration. Right? And that's going to be our answer for that. All right. So that's how U substitution tends to work. All right. So we'll do a couple more problems just so we can see what's going on with this. Yeah, let's go ahead. And this is a pretty typical example of splitting x e to the x squared dx. Now, e to the x squared by itself is not a function that you will ever be able to integrate. Okay, but because we have an x out in front here, we could say, oh, well, how about we say let u equal x squared du is equal to 2x. Now you could multiply by constants, okay, in order to fix what's going on here. So again, the way that I learned how to do this, we say 2x dx. We could say that dx equals du divided by 2x. And when I go to substitute, we have dx is equal to du over 2x. We have integral of x, e, and then we have x squared here, but u is x squared, so we have the u. The x cancels with the x, okay, and then there's a 1/2 here, so this is 1/2 integral of e to the u du. And this is an integral we can actually deal with. Okay, this is just going to be 1/2 e to the u, because the integral of e to the u is e to the u, plus our constant of integration. So we go back to x world and we say this is 1/2 e to the x squared plus c, and that would be our answer. Okay. With the way that I learned how to do this, we'll go back up here. We'll say this is the integral of x e to the x squared dx. And then notice my du, right, is 2x dx. So what I'm going to do is I'm going to multiply this by 2. I can't go around multiplying things by 2. That's not fair. So I'm really going to balance it out by saying, okay, I need to multiply by 2, but also by 1/2, because those will cancel out. And I really just multiply by 1. So these are going to cancel. So we're going to have 1/2 integral of e to the u, because it's in the x squared, and I've got my 2x dx sitting here. And this is my du. So this is 1/2 integral e to the u du, which is of course 1/2 integration of the u. Integration of e to the u is just e to the u plus constant of integration. So this is 1/2 e to the x squared plus c. All right. When you start getting, you've done a few of these, you go much faster, so you don't have to go through all of these different pieces. At the beginning, I would say going through the pieces, going through all the steps is probably a good thing to deal with, because I'll tell you this. At the beginning of U substitution, the choices for your U's are obvious, and you probably won't make any mistakes. You'll even get to the point of like, this is easy. How can anybody mess this up? You will mess up your U substitution. You will pick a wrong U and it won't work out correctly. Okay. Everybody does this. Okay. If you didn't do it, you'll be the only person who never picked the wrong U. Okay. So everybody picks the wrong U. It takes a little while into the class because we're trying to train you to pick U's. And then so they're all supposed to be really easy, right? You don't give fourth grade or 4-year-olds like, here, let's do fast pitch baseball for them. Like, no, let's start with T-ball. So the same thing. Like, no, we don't throw the hardest problem we can at you. We're like, here, let me set it up so that it's an obvious choice. Pick the obvious choice, and then say, okay, this is pretty easy. Once you start saying, oh, these are really easy, they'll start to get harder. Okay, and then you'll have a danger of picking the wrong U, which is okay. That's why we write it down, let U equal, so that you can go back and say, oh, that one didn't work. Let's pick a different one. Okay. Notice that every time that I go ahead and deal with my U substitution, I always say let U equal, because that's a good way of letting other people know what you did with the problem. So not everybody's always going to know exactly what happened. Let's try another one. Let's go with a integral of e to the x over 5, okay, dx. Now, this is the technique I'm going to show you because trying to memorize this exponential form can be a little bit difficult. So we're going to say let u equal, what's the problem? It's x over 5. My du is equal to 1/5 dx. Okay, it's just, mx must be kind of a thing. So what I'm going to do here is I'm going to say, well, we could either say dx equals 5 du, that's fine. Or what I'm going to do here is I'm going to say, here's my e to the x over 5. I need a 1/5 dx, but I can't go around multiplying everything by 1/5. You wouldn't like it if I multiplied your bank account by 1/5. No. We have to multiply by 5 times 1/5. This cancels out and makes a 1. So we end up with, here is my du. So we have integral of e to the u du. Okay, there's a 5 out front because I flipped to the integration. All right, integrating e to the u is very nice. So we end up with 5 e to the u plus c. And then we can go ahead and say, okay, this is 5 e to the, what was u? X to the x over 5 plus c, and there's our answer, and we're set. Right? So that's pretty much how you go through and do theirs. All right. Let me show you show you two that are kind of hard. Let's go with this one first. So I have integral of 1 over x ln of x dx. This problem is notorious in this particular class. Okay, I've taught this class a couple of times. This one integral ends people. So it's a good thing to be able to do, like find the u substitution for this one and be able to deal with this one. So we're going to say, let u equal, you have choices. It could be 1 over x, it could be x, it could be natural log, it could be 1 over natural log. Let's try natural log. Okay, so u is equal to natural log x. Du is equal to 1 over x dx. Notice, here's my 1 over x dx. I'm going to go ahead and substitute this 1 over x dx as my du. So this is going to be integral of, here's my du, and I have 1 over natural log, 1 over u du. So integrating 1 over u to u, we end up with natural log of u. It should be absolute values here, plus c. What the heck was u? U was the natural log of x. So this is the natural log of the natural log of x plus c, and that's my answer. Okay, so that's one that's a little bit tricky, but you should be able to get that one. Okay, next one is a little bit harder. So this is integral of 1 over e to the x plus 1 dx. Okay, so I'm looking at this one, and I'm saying, okay, well, what's my problem? I don't like this e to the x plus 1 on the bottom. Let's go ahead and deal with that. Let u equal e to the x plus 1. du equals e to the x is going to be e to the x. Derivative of a constant is 0, so du is just dx. Do I have an e to the x sitting here? No, I do not. I can't replace my e to the x with, my dx. I need an e to the x to match it. Right? My dx needs an e to the x, so it cancels out. So I only have these things in there. Right now, I can't do anything. You can say dx equals du over e to the x. If I go back and try to substitute, I have 1 over e to the x plus 1 was my new substitution. And in my dx, I've got du over e to the x. That doesn't help. I've got x's and u's inside of my integral. I can't integrate this. Okay, it doesn't work. So what I have to do is I have to be super clever. We're going to multiply by 1 in order to do this before we even get to the integration. So I have 1 over e to the x plus 1. I know, because we tried the substitution and failed, that I need some kind of an e to the x somewhere in my formula. So what I'm going to do is I'm going to multiply by e to the x over e to the x. But, and the bases are the same, we add the exponents. I'm going to end up with an e to the 2x here. I don't want to deal with e to the 2x. That's not going to quite work out. So instead, I'm going to change this from e to the x to e to the negative x. Because again, when the bases are the same, you add the exponents. X plus negative x will give me 0. So this is going to be integral of e to the negative x over, this is going to make e to the x times e to the negative x. This is going to be 1 plus e to the negative x dx. All right, so it's a little bit different problem than multiply by 1. Now what I'm going to do is say, let u equal e to the negative x. Du is equal to negative e to the negative x, right? It's e to the x times its chain rule. The chain rule of negative x is negative 1. Okay, so do I have an e to the negative x sitting in the numerator somewhere? I sure do. Do I have a negative side? No. But what I'm going to do is I'm going to multiply that by negative and multiply the bottom outside by negative. Negative times negative will be positive 1, so I'm not changing the problem. So here we have integral of negative e to the negative x divided by 1 plus e to the negative x dx. Notice my du here is negative e to the negative x. That thing now is a u, or du. So we have integral 1 over u du. Okay, my 1 plus e to the negative x, right? Go ahead and say 1 plus. When I take my derivative of a constant is 0, so this doesn't change anything. We have 1 over u du. Go ahead and integrate, and we have natural log of u plus c. What was u? U is 1 plus e to the negative x. So this is natural log of 1 plus e to the negative x plus c. Now, keep the absolute values there, and I'll show you what happens with the absolute values in just a second here. Do you remember what the graph of e to the negative x looks like? Sure you do. E to the negative x looks something like that. It's always positive. Something that's positive plus 1 is also always going to be positive. So I can drop the absolute value sign and say this is just parentheses 1 plus e to the negative x, which is a little less intimidating, plus c. You don't need to drop the absolute values, but, because absolute values can be intimidating, if I can drop them, I will, so that makes this just a little bit more pleasant to look at. That's going to be my answer, okay? Remember that your properties of natural logs. Natural log of AB is equal to the natural log of A plus the natural log of B. We use that a lot in this class. Do I have a natural log of A plus B? Can I say this is natural log of A plus the natural log of B? No, I cannot. Okay, again, that's going to be terribly wrong. Don't do that. You will be more sad than I will, but we'll both be sad that you did this. Okay, so we can't simplify this. We're stuck with it. This is all we can do with this because it's 1 plus e to the negative x. And that's great. We're stuck with the natural log of 1 plus e to the negative x. I'm sure that'll be fine. So, and it will be. Like, there's nothing more we can do with it. This is my answer, and we're done. Okay, so that is a trickier u substitution, but you had to multiply by 1 before you could get in and do the problem. Okay, we're going to do a couple more, mostly with limits now, so that you can see what happens when you've got definite interval rather than an indefinite interval dealing with u substitutions. Okay, so here I have 0 to 1. I've got 24x divided by, we have 4x squared plus 4. I think this is to the second power, dx. Okay, so the thing on the bottom, like this is a problem. Okay, so we're going to say let u equal 4x squared plus 4. Okay, because I don't want to have to multiply this out. I certainly don't want to have to do polynomial division to figure out what's going on. I can't, right? It's not going to work out very well. So my du is going to be 8x, derivative of the constant is 0, so we're just going to have 8x here. So I'm looking at this and I'm saying, okay, we have an 8x on the top here because this is the interval of 3 times 8x dx. And here I have a 4x squared plus 4. This is just u squared on the bottom. This piece here, that's my du. My 3 will float out in front. So this is 3 times the interval, okay, of 1 over u squared du, or 3 times interval, 0 to 1, of u to the negative 2 du. Now you have to remember, my limits are for x, okay? My interval is now in terms of u. So one thing I could do is say, well, remember that u is equal to 4x squared plus 4, so u equals 4x squared plus 4. I'm going to say when x equals 0, because that's my first limit, u is equal to 4 times 0 squared, which is 0, plus 4, u is equal to 4. When x is equal to 1, u is equal to 4 times 1 squared, which is 4. 4 plus 4 is 8. So we're going to say this is an interval from 4 to 8 of u to the negative 2 du. Just go ahead and integrate that. And that's going to be, oh, there's a 3 up front. Forget that. So we have a 3, u to the negative 1 divided by negative 1 from 4 to 8. So this simplifies. It's negative 3 u to the negative 1 going from 4 to 8. I'm going to do one more little trick. There's a negative out in front. I'm going to swap my limits of integration. I'm going to say this is 3 u to the negative 1 and go from 8 to 4. Right? When I swap the negative sign, that changes my limits of integration. So this is going to be 3 times 1 over 4, that's 4 to the negative 1, minus 1 over 8. That's 8 to the negative 1. And we'll figure that out. Okay? You have to get common denominators here. So that's going to be 2 over 2 here. So we have 3 times, I've got 2 over 8, 4 times 2, minus 1 over 8. Okay? 2 over 8 minus 1 over 8 is just 1 over 8. So we have 3 times 1 over 8, which is 3/8. And that's my answer for this problem, right? So there's a couple of different tricks in there dealing with the evaluation of the definite integral. Okay, again, if it's a definite integral, you do not need a plus c. Okay, if it's definite integral, you just plug in the limits and evaluate. You're fine. Okay, but that's another way. That's a way to do that. Okay. Let's see if we have another one here. I do, but we'll see. It doesn't look at it. Start with that one. Move that one. Let's okay, we'll do this one. Let's do this. Then it's kind of still a little bit. All right, we'll do this one. So we got -3 to 0. I have, looks like an 8x divided by 2x squared plus 3. And this is raised to the second power dx. Okay. So again, this is not going to be a fun integral. I can't do this the way it's written. So we're going to say let u equal 2x squared plus 3. And again, as soon as you take your substitution, go ahead and take the derivative. That's going to be 4x derivative of 3 is just 0. So we have 4x dx is equal to my du. All right, so here we could say, okay, we have dx equals du over 4x. Let's plug some things in. So we have -3 to 0. Remember, these are x's. Okay, I've got my 8x over 2x squared plus 3 squared. We're going to handle this in just a moment. Times my dx. But what was dx? Dx was du over 4x. There's some stuff that's going to cancel. So this is going to be 2, right? 8 over 4 is 2. Integral. This is 2x squared plus 3 is u. So we have u to the -2 here. And we went from -3 to 0. But I want to stay with u's. I don't want to go back to x's. Okay? X's seems kind of difficult. So we're going to say, okay, when x equals -3, u equals 2 times -3 squared plus 3. -3 squared is going to be 9. 2 times 9 is 18. 18 plus 3 is 21. Okay? When x equals 0, u is equal to 2 times 0 squared plus 3. This is equal to 3. So we're going to say this is the integral from 21 to 3 of u to the -2 du. Okay, and that's a 2 out front. Okay. So that's what you go ahead and do that. So be careful with how to do this. Again, all of this is just so that I don't have to go back to x's and plug in the 0 or the -3 to 0. I can stay here and plug in 3 and 21. So go ahead and integrate this. This is going to be -2 u to the -1, going from 21 to 3. So this is going to be twice. Was it negative? It was negative, wasn't it? So it's -2. I'll tell you what, we're going to do that trick again where I get rid of the negative sign and say, let's swap the order of integration. So we have 2 u to the -1 going from 3 to 21. And we'll see how that works. Okay, so this is going to be 2, and then I've got 1 over 21 minus 1 over 3. Okay, so we'll see what happens there. Let's go ahead and get common denominators. We have 7 over 7. So we have 1 minus, so we have 2 times 1 over 21 minus 7 over 21. 1 minus 7 is going to be -6. We have -2. We have 6 over 21 here. So the 3's are going to cancel. So we have -2. Let's see, 3's cancel. We have 2 7ths remaining. So this is going to be -4 7ths. And that's my answer for this particular interval. Okay, so that's kind of like a little idea of how we're going to deal with these substitutions. Of all the skills that we have in this class, I'd say U substitution comes up the most frequently. I would also go on to say that the success in the class pretty much depends on how well can you do U substitution? Like it's a huge thing that we do it a lot. Okay. So the better you are at U substitution, the better you're going to do in this class. Okay. So what I want you to do is practice U substitution until you cannot get it wrong. Right. And then go through and do that. And I'll say thank you very much for listening. Thank you very much for watching the video. And I'll see you in the next one.